Hello, and welcome to this video about permutations. In this video, we'll be learning how to create a permutation data type for your computer so that you can perform lots of functions on them. The first thing to learn is how to store them on your computer. There'll be two attributes associated with this data type. The first is the length of the list of numbers, which is also equal to the maximum of these numbers. And then there's the list of these numbers themselves, which contain the order of these numbers, which is the permutation. I've decided to store them as a single array, so that the first element stores the length of this list, while the rest stores the list, which is a convenient way to store this data type. The first function that we'll create is the function to create the identity permutation, which is all of the numbers in order, so nothing gets swapped or rearranged. It can be written as the number 1 with a subscript p, so that it represents the identity permutation and not the number 1. So the first thing to do is to get the length of this permutation, which should be passed by the parameter of this function called n. We then set the list of numbers to be all of the numbers in order. The next function is the concatenate function, or the application of one permutation onto another, so that the second permutation is swapped about by the first. So we'll get the length of one of the permutations, and assume that the second has the same length, and pass this value onto an independent variable n, that we can insert into loops, and onto the third permutation, which will contain the answer. This is the loop that swaps about the permutations and so gives us the answer. This is the permutation inverse function. Every permutation has an inverse that, when applied to it, gives us the identity permutation. We'll get the length of the permutation from the first permutation. Then we'll get the inverse permutation by swapping the index with the contents of the list. Now here's the function to raise a permutation to the power of an integer. It could be used for squaring or cubing a permutation by concatenating it by itself m times. We'll get the length of the permutation and pass this onto all of the other appropriate variables. Then we'll create the first loop to go through every element in the list of the first permutation. Then we'll create this second loop to calculate what applying the permutation done to a particular element m times would give. So this would give us the answer. So now to create a function that applies the permutation to a string of variables separated by spaces. We'll firstly get the length of the permutation. Then we'll turn the string into an array using this function. We'll loop through all of the numbers in the permutation. We'll then rearrange all of the elements of this string using this permutation. Now to check that a given list of numbers is a permutation must contain all of the integers from 1 to n, and each of these integers can only occur once. We'll firstly get the length of the permutation. We'll count the number of times each number occurs in the list and store this in an array called occurrence. We'll set all of the elements of this array to 0 because we'll increment them by 1 each time we find a particular number, and they have to be 0 initially. We'll loop through each element of the list in the order that we find them. If there is a number that is out of range, then this guarantees failure. We'll just set an occurrence value to 10, which seems simpler than declaring another variable. So this is where we count the number of times each number occurs in the list. This is the code where we check if it is a valid permutation. Each element should occur only once. We'll return the value in the variable called isAperm. This function takes a string in cyclic notation and converts it into list notation where it is stored. Here is what cyclic notation looks like. The permutation is stored as cyclic loops, so that, for example, 2 goes to 5, then 5 goes to 8, and then 8 goes back to 2. The length of the permutation is passed separately. So we'll add a terminating symbol or word to this string, and we'll set the permutation length. We'll set this permutation to initially be the identity permutation for all of the numbers not included in the cycles that don't get affected by the permutation. We'll turn this string into an array so that we can pass it more easily. This is what the function to get or pass the first character looks like. So we'll start the main loop here, which looks for the terminating character of the string. I'll just rewrite it out again here. We'll have a loop here to look for the start of the cycle, which is a left bracket. After that, we'll reset these index variables. Then we'll get the next character. I could just write it out like this because I've already defined it before. So this loop puts all of the numbers in the cycle into the permutation, except for the last number. The function called number converts the word ch into its corresponding number. I'll just rewrite this code to keep this loop together. The last line inserts the last number in the cycle into the loop. It does it separately because the number doesn't come after it in the cycle, and it has to remember what the first number was. Now for the function that can convert a permutation in list notation into cyclic notation, for example in this green rectangle. We'll get the length of this permutation, which is stored in the permutation attribute called length. Then we'll set all the markers associated with the numbers in the permutation to be 1 or true, and set each mark variable to be 0 when the element has been processed to stop cycles from being written twice. This is the string in which we'll store the permutation in cyclic form. We'll loop through all of the numbers in the permutation list. Then we'll set a variable to be equal to this particular variable and follow up where it cycles to. We'll start to make a cycle by adding an opening left bracket. This is a counting variable to count the number of elements in the cycle. If it's 1 or 0, we'll ignore it and print nothing. We'll start this while loop. We'll only enter it if the variable isn't already in another cycle. We'll exit when it reaches the end of the cycle. I'll just write this while loop at the top here, so we can see the whole loop on one page. When the loop is entered, then we'll immediately unmark this variable so that it won't be processed again. We'll then append this number onto the string. Then we'll get the next number in the cycle and repeat this procedure for it until it gets back to the original number. Then we'll count the number of elements in this cycle. We'll then add a closing bracket to show that this cycle is finished. But if the number of elements in this cycle is 1 or less, we'll ignore it by setting this string to be the empty string. We'll append this string containing the cycle onto the main string. The answer will be stored in this main string str1. So here's some of the computer code I wrote in JavaScript. I called the permutation pperm, and its length was stored in the 0 location of this array. They look very similar to the code that I described before in this video. These functions are short, but still complicated to look at. Here's the code I used to check if a list of numbers is a permutation. Here's the code that I used to apply the permutation to a string of elements, like letters from the alphabet, so they'd get swapped around according to the permutation. And here's a function to print out a permutation that's stored in P. Here's the code to transform a permutation from cyclic notation into list notation. It uses parsing techniques used to compile computer languages, like a next character function. Here's a function that does the reverse of this. transforming a permutation from list notation into cycle notation. So I hope that you found this video helpful and interesting. I wish you a lot of luck in your quest to study this sort of math. Please click like and subscribe if you have. Please write some helpful thoughts in the comments if you can. And thanks a lot for watching.